Time for some new derivative rules. We're going to determine the derivative of the 6 trigonometric functions, starting with sine and cosine. To determine the derivative of y equals sine x, we're going to go to the definition. The limit, as h approaches 0, f of x plus h minus f of x all over h. And in this situation, f of x is sine x. What would f of x plus h be? Everywhere you see an x, we're going to replace that with x plus h. So f of x plus h would be the sine of x plus h. So instead of f of x, we're going to put in sine x. Instead of f of x plus h, we'll put in sine of x plus h. So this is what we're trying to work out. Now, it turns out that we have a trigonometric identity that will help us do this. So how does this work? We are going to say that A is x. Okay. And B is h. So we get the sine of x plus h, which is what we have right here, is going to be replaced with sine x cos h plus cos x sine h. And that's just using a trig identity. What we're going to do now is look for terms that have something in common. I see sine x in this term and sine x in this term. So we're going to put those two together. So there they are together. And it's even better if we really separate them so we can see what's going on. So we said we'll take this fraction, put it over here, take that fraction and put it over there. Now we're looking to factor. Can you see anything common that we could get rid of? We've got a sine x and a sine x here, so we can pull that out front. Over here, there's nothing common except all these have h's in them. So why don't we keep the terms with h's in them together and all the terms with x out front? So what does that look like? We factored out the sine x, leaving us with cos h minus 1 over h. This one, we pulled the cos x out, leaving it with sine h over h. And this leads us to a couple of very special limits. So the limits we're going to look at, sine h over h, and then cos h minus 1 over h. So to evaluate sine h over h, put your calculator in radians. We're approaching 0. So I'm going to take a number reasonably close to 0, just get an idea of what I'm doing. So if I plug in 1, and you can do this on your calculator, sine of 1 over 1. If your calculator is in radians, you're going to get 0.8414709.8. We can get closer than that to 0. So let's get closer. Put that in your calculator. We're getting 0.999998, bunch of 3s. Get even closer, and we get 0.9999999. So what does it look like this limit is approaching? What number are we getting closer and closer and closer to? And I would say that that number is 1. So this limit is 1. We're going to do the same thing with cos h minus 1 over h. Put your calculator in radians, pick an easy value that's close to 0, calculate the cos of 1 minus 1 over 1, cos of 0.01, and the cos of 0.00001 minus 1 over 1. And what are we approaching this time? Goodness, this is getting very, very small. I would say that that's approaching 0. And there we are. That limit is 0. So what happens if this is going to 1, this limit, as h approaches 0, sine h over h goes to 1, and this limit goes to 0. What will you be left with? We're going to do it again on the next page. This is where we left off with. So we said this limit is equal to 0, and this limit is equal to 1. Well, 0 times anything is 0, so that's pretty simple. And this one, 1 times cos x. And what impact does h have on x? Nothing. H is going to 0. That doesn't change x. So we just get 0 plus cos x. Interesting. So what we've discovered, I'll get rid of that stuff for you. is that we're multiplying by 0, we're multiplying by 1. Our final answer is cosx. So the derivative of sine is cosine. It's a really important rule that you're going to memorize. You don't ever have to recreate what we just did, and you don't really have to completely understand it as long as you have a bit of an idea of what just happened. And for those who like to think about it a different way, this is the graph of sine x. If we calculate the slope of the tangent, the slope of that tangent is 0. Slope of this tangent is 0. Slope here and here looks a lot like 1, going up at about 45 degrees. What about the slope here? It looks like -1. What kind of graph do we get when we graph the slope of the tangent? I'm hoping you instantly recognize that as the cosine graph. So again, the slope of the tangent of the sine graph, or the derivative of the sine graph, is the cosine graph. How cool is that? Let's do the same thing with the derivative of cos. If you think you understand what you're doing, try it yourself. If you want to work with me, we'll keep going. We'll go to the limit. Our function is f of x equals cosx. If we replace all our x's with x plus h, we would end up with f of x plus h equals cosine x plus h. So f of x plus h will be replaced with cosine x plus h. So that goes instead of f of x plus h. F of x goes instead of f of x. All right, so we get the cosine of x plus h minus cos x over h. There's another identity. This one, cosine of a plus b equals cos a cos b minus sine a sine b. If you're wondering about these, there was a little optional section that you could look at, and that will tell you where these come from. So what are we doing? Cosine of x plus h. So x and h, x and h. So this will become cosine of x, cosine of h, minus sine x, sine h. And then remember, minus cos x. Do what we did before, look for terms that have something in common. Those both have a cos x. We'll put those together. And then again, to make it obvious, we'll just separate them. So we have the cos x cos h minus cos x over h, and the sine x sine h over h. Factor out the common terms. Those are common. And then again, we'll separate the x's from the h's. What do we get now? Our common term of cos x came out. It's multiplied by cos h and 1 all over h. This one, if we pull the sine x out, multiplied by sine h over h. And then we get the same special limits that we had before. Again, feel free to try and figure this out on your own. What does this limit equal? And what does this limit equal? If we look at it on the next page, this limit is equal to 0. So when you see the limit as h approaches 0, cos h minus 1 over h, that's 0. This limit, sine h over h, limit h approaches 0. One is 1. And then we write down our other terms. We have a cos x, which it's not affected at all by the h approaching 0. And we have a sine x. So when you multiply those together, what do you end up with? Minus sine x. So the derivative of cosine is minus sine. Again, for those who want to see it graphically, this is the graph of cosine. Let's look at slopes of tangents, because the slope of the tangent is the derivative. Slope of the tangent is 0, 0, 0. Slope of this tangent going down at minus 45 degrees is minus 1. Slope of this tangent is 1. What graph do you see? That looks like an upside down sine graph to me, which is negative sine x. So what you've learned so far, derivative of sine is cos, derivative of cos is minus sine. And then we're going to use these to find the derivatives of the next 4 trig functions. And I'll put that on a different video.